This is chapter 8 from the textbook. It starts with some basic descriptions, the difference between distance and displacement, and they even give you a three-dimensional picture. I'm not sure you need to know, because nothing there talks about considering solving problems involving motion in 2 or 3 dimensions. So you don't really need to know it, but I'll tell you anyway because it's vectors, and your levels have not done much vectors yet, even in physics. Yeah. So we're going to do, I don't even know what to call this. I'm going to call it linear motion, even though we're going to start with some non-linear. So you understand the words, you need to understand distance. I'm writing them like this for a reason. The Year 12s understand. Why I've written them like that. You have to know what these words mean because you will see them. Oh, these little kids who come in here in the morning, they've now run out of sticky tape, so now they're playing with the masking tape. Oh. Okay. Eddie and Travis, what's the difference between distance and displacement? Either of you.
Displacement's like in a direction.
Correct. Scalar, vector. This one has a direction. What's the difference between speed and velocity? Exactly the same. This one has a direction. Acceleration is a vector. So for example, if I go north for 3 kilometres and then I go east for 4 kilometres, the distance I have travelled is 7 kilometres, but my displacement is 5 kilometres. Well, it's north, 53 degrees east. I have to give a direction. Does that make sense, April and Xander? Again, the syllabus itself doesn't talk about this specifically, but you will see these words in various places and you need to know what those words are talking about. You will need to know these words when, that's Unit 1 vectors. We'll start talking about these kinds of things. So I'm going to skip quickly through some of this stuff. Do I need to give you some definitions? Average speed is distance over time. Maybe I should say total distance over total time. Where's an eraser? Oh, really? Masking tape. Total distance travelled divided by the total time taken. I think they even have average acceleration in this book, don't they? It's probably worth, average, no, it doesn't do it. We will normally not do much with this kind of average. We actually want instantaneous, almost always. Almost always. Instantaneous velocity is displacement over time, but it's actually the change in position divided by the change in time. You may also see this written as x dot or x dashed. Be careful with the dash. The dot specifically means derivative with respect to time. The dash just means derivative. And we are going to, if you look at the syllabus, we are going to be doing some of our derivatives not with respect to time. So be very careful with the dash form. And likewise, acceleration is, I'm going to need more room for acceleration, is dv dt, which is v dot, oh, why did I write that up high? V dot, or v dashed, but v is a derivative. So acceleration is also d squared x dt squared, second derivative of x with respect to time, or x dot dot, or x dash dash. Again, be very careful with the dash versions. I encourage you either to use the full derivative notation or the dot. I want to discourage you. This is technically correct but could be confusing. Try to avoid that one. But wait a minute, that means I can write some more relationships. Because if acceleration is the derivative of velocity, then velocity is also the integral of acceleration with respect to time. And then displacement is the integral of velocity with respect to time. Whoops. I'm going to give you some simple examples and then some more complicated examples. Oh, there's one more thing we're going to need to know, isn't there? There is. If I have an object and I let it go, what happens? What did it do?
It fell.
No, using this language, what did it do? Accelerated towards the ground at what rate?
9.8
units?
meters per second. Square.
Meters per second, correct. Okay, so you will need to know acceleration due to gravity is 9.8 meters per second per second. I've gone second to the -2 because I'm a physics person. You can write /s/s. Gets a bit tiring after a while. Let's try a few questions. I'm going to skip the averages, I don't care. So, a particle, well, it's always a particle or an object or a thing or a point mass or whatever. A particle moves such that its displacement pardon me, is 2t squared minus 3t plus 1. What did they say? Determine its acceleration.
So we just derive it twice.
Derive it twice. Velocity is x dot, or you can write dx dt. I will do that later when we start doing the confusing ones. Dot always means dt, always, which is 4t minus 3. if t is seconds and x is meters, that's 4 meters per second per second. I'm going to combine a couple of questions. Or maybe I'll just... No, let's do it. Determine its velocity after 7 seconds. So what do I have to do, April? Where's my equation for velocity?
Replace 7.
Put t equals 70. Yep, that's what you got to do. B equals 4 times 7 minus 3, 25. Again, it might, if this was meters and seconds, it might be meters per second squared. This one will be meters per second. Too easy, right?
Sure.
That was constant acceleration. I will give you one more with constant acceleration. A body, don't think a dead body, all right? We're not talking about a dead body. A body, a thing, an object, a particle. A body moving in a straight line has acceleration -2 meters per second per second. And it starts 3 centimeters. Do you want to go minus? That'll do. Left of the origin with initial velocity. So we're in centimeters. Is that meters per second or centimeters? 3 meters, that's my problem, I can't read. Okay. It starts with initial velocity 12, positive 12 meters per second. Determine an expression for its displacement at time t seconds. This one's going the other direction, that's why there's more information. We're going to have to integrate and work out constants. We're going to go from displacement, we're going to go from acceleration to velocity, then velocity to displacement. So I have acceleration -2. So my velocity is the integral, that was a messy equal sign. It's bothering me. Velocity is the integral of acceleration with respect to time. Do I have to move this yet? Nearly. Integral of -2 dt, -2t plus constant. Okay with that so far? All right, I need to work out this constant. I've got its initial velocity. So, at t equals 0, v equals 12, which has to be c. That was nice. Therefore, v is 12 minus 2t. You can write negative 2t plus 12 if you want to, it doesn't really matter. If you have done physics, Travis and Eddie, u plus at. That's where the formula is. But in specialist maths, you are not allowed to just use the formulas. You must do the integration. Okay, displacement then is the integral of velocity with respect to time. I am going slower for the Year 11s to keep up.
Yeah.
Integral of 12 minus 2t. I do not mind if you skip one or two of these steps. It is important you show me you know you're doing an integral, like one of these lines at least. 12t minus t squared plus constant. I used a different letter. You'd probably get away with it, but it's better if you use a different letter. It will be clear enough from context you're talking about a different constant, but just to be clear, I use a different one. I need more information to work out that constant. Where's my additional information? Starts 3 meters left. So at t equals 0, x is negative 3. Which is, this is 0, this is 0, that's going to be d. Therefore, x is 12t minus t squared minus 3. ut plus a half t squared, half a t squared. Think you could do that? Do you want to make it a bit harder? Okay, I'm at 8.2 now, if you're following along. The displacement of an object moving in a straight line, because that's what the syllabus says we have to do, x meters time t seconds is, x function of time is negative 2t cubed plus 3t squared plus 5t minus 6. Nice, okay. A, determine displacement, velocity, acceleration at 1 second. A, determine displacement, velocity, and acceleration after 1 second. Notice the way I summarised what they said in the textbook? This means displacement when t is 1, velocity when t is 1, acceleration when t is 1. And you can go ahead and work out x at 1 straight from what you've got there. Off you go. Give me an answer in meters per second. No, sorry, just meters, isn't it? Just meters. Yeah, that's all you've got to do. It literally is that easy. I'm going to get negative 2 plus 3 plus 5 minus 6. That's 1, 6, 6, 0. It's at the origin. Okay, to get velocity I need to work out first x dashed at time. Should I do that? Or will I just write x dot?
Same thing.
This is clear in this case because I'm telling you what the variable is. So the dashed is okay. That's why my natural inclination is to write the dash, because I've got the variable. Differentiate with respect to time. Off you go, then substitute the value 1. What did you know, Eddie? Done the whole thing already?
Oh, yeah.
Oh. Okay, without looking, part B says, what are the other times when the object is at the origin?
Oh, so it's cubic.
Okay, differentiate. Derivative of this with respect to time is minus 6t squared plus 6t plus 5.
Oh, I didn't, but that might have been my math.
Did you do something wrong?
Velocity.
Oh no, I did something wrong.
Okay.
Negative 6, negative 6 plus 6 plus 5 is 5 metres per second. To the right.
Yeah.
Do we need to write that it's to the right?
Not if it, the question itself in this case tells us moving to the right is positive, so you should be right. Depends. If you're giving a word answer, I would. I'd go, after 1 second, the velocity is 5 metres per second to the right.
If you got negative, then it's to the left.
And it was my answer was negative 5, and I'll go, therefore it's moving 5 metres per second to the left.
In this context, could it technically be like going up and down?
It's in a straight line, but the question specifically says to the right.
Okay, yeah.
To the right is positive, it says.
Yeah.
And acceleration is derivative of velocity with respect to time. April and Xander, you keeping up with us?
Yep.
Okay, good. Negative 12t plus 6. A of 1 is negative 12 plus 6, which is negative 6 metres per second. Am I right, Ryan?
I don't even see.
Beautiful. Question answered. B.
Huh?
Acceleration.
Acceleration should be negative 6?
Yeah.
Yes, okay. B. Determine the other times when the object, the object is at the origin.
And displacement equals 0.
Set displacement equals 0 and try to solve. Can you do that? Oh, we haven't actually done this little bit of it, have we?
What, long division?
Yeah.
Well, we learned it long division.
In methods?
We did, but like, don't you need a
I have one.
Okay. Yeah.
I have a factor.
You can do it without factor.
Wait, let's make sure April and Sandra are keeping up with us here.
Yeah.
How do I do this? I have to set x equal to 0. X of t has to equal 0. It's a cubic. If I'm going to solve that equal to 0, I have two possible strategies. One is to factorise, and the other is to draw a graph.
That's cheating.
Your exam is tech active.
At the end of year.
Correct. So, if I'm going to do it by factorising, I need to find a single factor of this. I already know one. Remember, did you do this in methods as well?
Yeah.
So, if its value at a particular time t is 0, that means t minus 1 is a factor of this. So I can write it's t minus 1 times at squared plus bt plus c. That was a bit messy. At squared plus bt plus c. I'm going to do this without long division because it's a pretty simple one. If I've taken out a factor t minus 1, I know what's left is going to be a quadratic. I just have to work out what a, b and c are. You done with this method, Eddie and Travis?
Yeah, but I'm not as confident in it.
It's much quicker for a simple one.
Like when you get to like degree 5, or that sort of. Like,
Sure.
Yeah.
I think it says degree 4 in the syllabus.
Okay. I remember seeing a method that went up to.
To order 4.
Okay.
Yep. So, a has to multiply by t squared and t to get negative 2t cubed. A has to be negative 2. Okay? A must be negative 2. C has to multiply by negative 1 and get me negative 6. So C must be negative 6. I would actually normally just write negative 2 and negative 6 here because I can see them so quickly. B is harder. What do I know about B? It comes from, I'm looking for either, I can use either term, I'll get the same answer. Let's look at the t squared term. I know that 3t squared has to come about from this and this, this and this. So t squared has to be negative at squared plus bt squared. And I know a is negative 2. And I can get rid of the t squareds. So 3 is negative of negative 2 plus b. Did you do long division?
The first one, yeah.
Yeah, I got it.
Yeah. That's what I got.
Okay. Well, am I getting the same answer as you so far?
Yeah.
Okay. So that means 3 is 2 plus b. B must be 1. Do you agree?
We got plus 6.
No, wait. That's for B, which is the middle one.
That's the middle term here.
Minus 2
C is.
Negative 6.
We got positive 6.
Oh yeah, I got positive
We
6.
got positive 6.
For which this?
To C.
C.
Negative 1. Oh,
Long division.
6. My mistake. Okay. Therefore, well, x of t is t minus 1, negative 2t squared plus t plus 6.
Yep.
Then I have to factorise one more time.
Wait, is it not minus 6?
No, that was my mistake.
6.
Negative 1 times c has to equal negative 6. So c actually has to be positive 6. My mistake. Put these over at the side, out of the way. My mistake.
Yep.
Okay, factorise this. Two numbers that multiply to negative 12 and add to 1. 4 and 3?
Yep.
Okay, I'll do it my way. I've got negative 2t squared and t squared. And I want to get 4 and 3. 4, so negative 2 and 3. T minus 1, negative 2t squared, take 2. Plus 3, t squared, take 2.
They're both T's, but yeah. Not T.
Oh, sorry, they're both t's,
Yeah.
not t squared. My fault. My fault. Is that what you got?
Yep.
Equals 0 when t equals 0, already knew, no, sorry, t equals 1, already knew, or t equals negative 3 on 2, or t equals 2.
Do we disregard that middle one though?
What did the question say? At time t seconds, it doesn't say after t seconds. They discarded it because it wasn't,
Okay.
they discarded it.
Because they didn't mention like a domain.
No, they didn't.
Time can't be negative though.
Oh, yes, it can. Depends where your origin is.
Like if it happened 10 seconds ago.
The question didn't say that,
Yeah.
but in their solution, they've assumed it. Therefore, also at origin at t equals 2 seconds. You can decide whether or not to ignore this solution here.
It's accelerating but moving straight. So
It's accelerating like this.
faster or slower.
Down back and forth.
Yes, it is. Yes, it is. Determine the time when the body is moving at maximum velocity and the value of the maximum velocity. Methods, here we go. Determine when max velocity and what is this maximum velocity. You can tell I'm getting tired because I can't bother writing all those words. You can go through a full factorisation here. I'm just trying to speed things up by using my old method. Okay. How do I know when I've got the maximum velocity? One of the year 11s, please.
Can't we just solve for the derived x?
Yes. Well, which derived?
When you derive x, you have the velocity thing.
How do I find the maximum velocity?
With the acceleration.
Correct. I've got to derive the velocity to work out the maximum velocity. So I'm going to work out when the acceleration is 0.
Yeah.
Does that make sense, Ryan?
Yeah.
Yep, okay. So, I'm going to set acceleration equal to 0. Where's my acceleration? Is it the one? This one. Negative 12t plus 6. T, it must be, what's funny there for? T must be
Half.
at which time v of a half is my velocity. Oh man, negative 6 a half squared. What's my equation? Plus 6 times a half plus 5. Negative 6 on 4 plus 6 on 2 plus 5. So that's 3 on 2, so that's 3 on 2 plus 5, which is 3 on 2 plus 10 on 2, or more conventionally, 6.5 metres per second. Have I technically finished yet? No. Can I convince myself this is actually a maximum? Just because acceleration is 0 doesn't mean it's a maximum. How do I know that's a maximum?
Do you want to derive it again or like plot it?
Either of those is a good strategy. How about this? I know the velocity has been 5 metres per second. This is bigger than that,
So it can't be a min.
so it can't be a minimum. So I'm reasonably confident it's a maximum. You could put in velocity at 0. You've already done velocity at 1. Convince yourself it actually is a maximum. I'm too lazy. There is no reason why this has to be a polynomial. This could involve sine or cos, and it will later. Simple harmonic motion, which is up there, right at the bottom of the modelling motion section. Simple harmonic motion involves a cos or a sine. So that's coming. This could be anything. You just differentiate or integrate depending on which way you have to go.
So you just do the same thing, but
Yeah, you
Different
do the
functions.
same process, but it'll be slightly harder for calculus. I'm going to leave the different notation. I'm not going to do that in one go. I will mention one more thing. Displacement, no. Displacement, time. What is the gradient?
negative.
Okay, it's negative. What kind of a thing is it? What does it represent in real life?
That you've gone back.
No, not necessarily, because I started here and now I'm here, so I haven't gone back.
Yeah.
I've gone back a little bit. These two have done physics. Most of you have done 10 physics at some point in your life. Remember what the gradient of a displacement time graph is? Correct, it's the derivative.
Yeah.
What's the derivative of displacement over time?
The velocity.
Correct.
Yeah.
The gradient is velocity. Velocity, time, no, I always get that the wrong way around. Velocity, time. What's the gradient of this graph represent?
Acceleration.
Correct. What's the area under this curve represent? That's harder.
Displacement.
Correct. Because I'm getting, imagine this was like a rectangle or something similar. I'm going velocity times the time you're travelling at that speed. So this, which is actually, let me go C and D. This area, I know I'm going to run out of room, I'll do it there. This area is the integral from C to D of velocity. That's the displacement over that interval. Now, year 11s, I haven't actually taught you how to do this, but you can work out x at this point and x at this point and subtract them, which is actually exactly what this means. Work out displacement, substitute D, substitute C, subtract. And that tells you the amount you've moved in that time. Acceleration and time. Eddie and Travis know what the gradient represents.
Jerk.
Jerk. We don't need to do jerk. But what's the area under that curve represent?
Velocity.
Correct. Well, actually it's change in velocity.
Well, yeah.
EF. This integral from E to F is the change in velocity. Technically, this should be change in displacement, change in position. Unfortunately, the word displacement is used ambiguously.